So I'm Sam, and I have Vadim here with me today to talk about what we've been doing with AMP at Pinterest. So the title is a little bit sensationalist, but we actually do have about 1 billion pages that we're serving on AMP right now. Next I want to go and talk a little bit about what we actually do at Pinterest. So Vadim works on user acquisition, i.e. introducing new users to Pinterest, getting as many new users to Pinterest as possible. Myself, I work on performance, so performance on the web, performance on our mobile apps, backend performance, you name it. So for me personally, AMP is a real boon. Speed matters. Next up, I want to talk a little bit about Pinterest. Most of you probably have some idea of what Pinterest is, but it's always kind of good to talk a little bit about how we actually view Pinterest. So for us, Pinterest is the world's catalog of ideas. We have about 100 billion pins of Pinterest. Each one of these represents some piece of content. Those pins have been organized, categorized, and curated by our users into about 2 billion boards. And this kind of categorization or this platform allows us to help people discover things. It allows us to help people find things they love and want to do. And that's kind of how we view what the mission of Pinterest is. And so next, I want to talk a little bit about AMP at Pinterest. So why AMP? And this is kind of a theme that you'll probably hear over and over again during this conference. So our primary reason for doing AMP is all about speed. So we're not the first people to discover this, obviously, but faster loading pages mean more engaged users or a better user experience in general. But not only that, speed also does matter for search ranking and similar things. So faster speeds also drive more traffic for us. And so how are we using AMP at Pinterest? So it's primarily served to our unauthenticated users. And it's currently primarily for our pin pages. So what are pin pages? Pin pages are the pages that are centered around a singular piece of content. And contrasting that, we also have other types of pages, which we typically refer to as collection pages. And these are things like boards, as I mentioned previously, where users have curated content. But we also extract signal from user curation and aggregate further around other keywords and things like that. But for now, we've started with pin pages, and we'll probably begin rolling out AMP to other page types over time. And so these types of pages, the pin pages, get traffic primarily from various referral sources. So we've got Google, Facebook, Twitter, other search engines. And most importantly, this is how a lot of our new users end up discovering Pinterest. You search something on Google, you find a result on Pinterest, you click on it, that's kind of your initial user experience. So it's very important that it's fast, gives a good impression to our users. So what does this actually look like in practice? So on my right, you can kind of see where we started. This is our non-AMP mobile page. On the left is where we landed with AMP for these pages. One of the main differences here is that we've decided to treat the content slightly different. So the non-AMP version does have the first pin, which is really the main piece of content for this page, as part of a grid or a masonry-style layout, and it isn't very highlighted. But looking at the ecosystem and looking how AMP is being displayed and used right now, we figured it was really much more about the singular piece of content. So we decided for AMP to go and highlight that much more, bigger image, and below that there's a whole bunch of metadata that you can't necessarily see. So we may have structured data in there as well. For recipes, for example, you might have a list of ingredients. And then below that, we actually serve related content. So you get the main piece, and then in the second screen over, these are sort of the related pieces of content that we've associated with the main piece. So how did we actually do this? So first of all, in terms of rollout, even though this is not on the slide, we started basically with creating a separate path for URL path for AMP pages, and then through an experiment, kind of rolled out the link between our original pages and the AMP pages, and kind of checked for our typical metrics. And Vadim will be talking a lot about our metrics on how AMP was performing versus our normal pages. Now, in terms of actually kind of getting an AMP page rendered, so Pinterest started a journey about a year and a half ago to switch all of our web stuff to React. We're pretty close to the end of that journey, but since that's kind of our web stack, and we were already doing a bunch of server rendering for React, that felt very natural for us. So we end up producing AMP on the server using server rendered React. We did end up forking our code base to do this, primarily because the way we were doing CSS in our regular code base wasn't actually compatible with AMP. AMP elements I think we could have dealt with, but the CSS handling made it so that we couldn't really necessarily reuse what we had exactly as it was. That said, over time we may consider reconverging our code. The second thing is we also had to create a new render path. So typically our developers don't really go and implement entire pages. They go and implement pieces of a page, typically just within the body. So developers typically don't really get control over the entire page. So for AMP, since there's boilerplate and similar things, we had to go and create a new path for that. We also ended up wrapping some of the AMP components that are out there with our conventions. So what that looks like, it's kind of a trivial example, but this is how we end up calling AMP pixel. So we throw in a whole bunch of parameters in there that we always use. And also, ultimately, I think, do a bunch of things here, although not with this one, to make it extensible. This is kind of capturing convention for us. Oh. There we go. Back button was hard to find. And finally, there was a minor issue with React and AMP. So React likes to swallow attributes it doesn't really recognize. So we had to go and globally whitelist some of the AMP-specific element attributes. And so next I'm going to talk about what it took to actually port our features. And the major issue there, I think most of our pages are fairly straightforward, but the major issue there is what do you do with the Pinterest grid? And to begin with, what actually is the Pinterest grid? So it's a masonry-style layout. You can sort of see examples all over the web. But in practice, there are some things to call out that aren't necessarily always considered. So it's responsive. So different screen sizes, different orientations change the layout. It deals with variable height content. And this is important because typically you actually have to render this client side to be able to measure the height of this content. And then it's also filled the shortest column first. So typically the way content ends up on the grid is you go across the first row and then you pick the shortest column after that and then you fill it. And the reason why that is important is twofold. One is that we like to rank our content, right? And so when you fill it this way, you end up with most highly ranked content first. And the second reason is that it gives you the least ragged bottom in some ways. Although typically in our case, we do infinite scrolling, so you hopefully don't really get much of a bottom, but it's nonetheless important. So how did we take this to AMP? So you need the height of items, but you can no longer really measure it using JavaScript on the browser. So the only way to do this is ultimately through CSS. And so we took a look at a bunch of different mechanisms out there for achieving this. The first one was to use CSS columns. And there are always going to be some trade-offs with these approaches. But in this case, it's filled top to bottom. So first column down, second, et cetera, and then left to right. right? The result of this is usually the last column looks kind of pretty off. But that wasn't really such a big deal. We could have lived with that ultimately. The killer, though, was that it turned out to not really work that great on iOS. So you'd kind of scroll, but the image placeholders in iOS would actually never render an image. And yes, there are workarounds, or there were workarounds. There are workarounds for this, but they are not very performant workarounds. So we ended up abandoning this approach, and instead ended up here. So we made some trade-offs with respect to how we deal with variable height parts of the content, and kind of estimated the height and put the height in a fixed height container, where we get a sort of a bunch of buckets, height buckets essentially, that we categorize the content into. And then based on that height calculation on the server, we're now able to calculate the absolute positions of each individual piece of content for each screen size that we care about. So we have to basically worry about each column stop. So typically we deal with anything from 2 to, say, roughly 12 columns. So we do that calculation for every one of those column widths, or column number of columns. And this worked fairly well, especially since in the meantime, we've kind of looked at our representation of content a bit more and optimized it somewhat more for conversion. And on mobile, we end up with something that you see here, which really doesn't have a whole lot of variable height elements in here. So that kind of took away a lot of the problem as well. Some other things we did look at. We also looked at Flexbox. I mean, it has the same fill issue as CSS Columns. But more importantly, since it requires wrapping, you still have to actually figure out the height of the overall container. So it doesn't really actually buy you a whole lot. And then finally, we also took a look at CSS Grid, the CSS Grid spec. The problem there is that I think that would give us a workable solution, but none of the mobile browsers actually support it yet. All right. Next up, so what did we actually do about infinite scrolling? And we don't really have JavaScript. And the dead simple solution here was to just put more content on the page. It's what you can do. In practice, so we end up on a typical mobile page. We typically, I think, put something like 8 pieces of content on it. For AMP, we decided to go with 50 pieces of content. The way this still, the reason for why this actually still works fairly well is that AMP lazy loads a lot of things below the fold. And so from a page weight perspective, you still don't end up loading a whole lot of images with the page. The page still renders very fast. We will take another look at this, though, and do some analysis of how many users actually hit the bottom of this page. If it turns out that there are a lot of users that kind of really would like more content, then we'll probably go back and try to figure out a way to make this work within the AMP project itself through some sort of contribution. So next up is my colleague Vadim, who's going to talk about what we ended up doing to integrate with metrics. Thank you.
Thanks, Sam. I'm going to start from talking about metrics integration for AMP. And at first, let's take a closer look at Pinterest. Pinterest is a metrics-driven company with a lot of data and a lot of users. We have more than 150 million monthly active users and more than 100 billion pins. More than 400 engineers heavily rely on internal components to do the measurements and internal tools for analytics and experiments. For our team, we have 3 key metrics. The first one is sessions. It is the amount of unauthenticated unique users visited Pinterest. The second one is conversion rate. It is amount of unique unauthenticated. The second one is conversion rate. It's amount of unique users registered on Pinterest divided by session. And the last one is page load timing. we measure how long does it take for a user-visible part of a page to load. Let's go over details. How do we measure these metrics? To do that, we use in-house analytics system. And sessions are measured on the server side. We log every request and analyze it later. Conversions are measured via tracking users' lifetime. It's done via assigning every user an ID and store it in cookie, as well as tracking when they install the Pinterest mobile app or register via the website. Performance metrics are measured using JavaScript on the client side and reported via the Pinterest Analytics API. To improve these and other metrics, we run a lot of experiments, and we can do that on the client side or a server side. We also support classic A/B experiment, as well as page-level experiments. When we started to migrate to AMP, we've discovered that there wasn't an equivalent for everything. There is no way to measure sessions server-side, since AMP pages are delivered from Google's AMP cache. Conversions can be tracked via AMP client ID, but there is a risk of double counting users, because there is no easy way to bridge the client ID with our internal user ID and unifies users' AMP and non-AMP sessions. Performance metric can be reported via AMP Analytics and AMP Pixel, but do not provide an exact equivalent for our custom metrics. Client-side experiments could be run with AMP experiment, but would require reporting data back to us. Serverside EB experiments are not available, and we need to find a workaround for it. To sum up, AMP Pixel and AMP Analytics have 3 big instrumentation challenges, which we needed to solve before making a full switch to AMP. The first one is to figure out how to replace server-side metrics and EB experiments. The second one is that due to third-party cookie restrictions, in some browsers we can't have unified AMP client ID and internal Pinterest ID for new users visiting AMP pages. One AMP client ID could have multiple Pinterest users' IDs, and AMP client IDs couldn't be passed to deep links and Pinterest URLs. It makes it impossible to correctly attribute app installs to AMP sessions, and users could be double counted. We need to bridge these IDs to correctly track users and conversions. The last one is that since Pinterest uses custom performance metrics, which are measured by JavaScript, they should be added to AMP HTML project. Now let's talk about how did we solve these challenges and what trade-offs it required. Counting sessions was the easiest issue to resolve. We introduced a new endpoint on Pinterest and use AMP Pixel to call it. The call creates a new synthetic request entry in our logs, which we use to capture AMP page loads. For server-side EB experiments, we have 2 options, and we can pick one of them based on the experiment in question. The first option is to convert the experiment from a user-based EB experiment to a page-level experiment. This way, we'll still be able to control it on the server side, but lose the benefits of a classic EB experiment, like getting statistical significant metrics differences. The second option is to use client-side AMP experiments. Let's imagine that we need to slightly change every image on the page. Since there is no JavaScript, the only option is to fully replicate all pins and have both control as well as treatment data stored inside the page. It would slow down page generation on Pinterest server side, since we need to get data twice for both control and treatment, and would significantly increase page size. Page becomes slower, and it could affect search traffic and user conversion metrics. Also worth mentioning that in both approaches, there is a downside that there is no easy way to instantly start or stop experiments due to AMP propagation delay, or time for which pages are cached in Google's AMP cache. The next thing we needed to solve was how to not double count users and bridge the AMP client ID with Pinterest user ID. This problem exists because Pinterest domain becomes a third-party domain to AMP pages. In this case, AMP pages do not have access to Pinterest cookies, and Pinterest may not be able to set new cookies due to browser settings. This means that we can't rely on our own user ID anymore, since one AMP client ID could have multiple Pinterest user IDs. And to calculate conversions correctly, we now need to have the ability to pass AMP client IDs as a parameter to Pinterest URLs and deep links. This capability was not available right away, and we worked together with the AMP project team to make the required changes. These changes were released recently, and we're updating our internal data workflows to account for AMP client ID. The last thing we needed to resolve was performance metrics. Our internal key performance metric measures when user-visible elements in the user's viewport are finished loading. In AMP, images are lazy loaded below the fold. And at first, we've decided to use existing DOM-complete metric as an approximation. Recently, a new event, ini-load, was introduced in AMP Analytics triggers mechanism. It allows to measure when all elements above the fold finished loading, and it's exactly what we need. Let me sum up. We've solved how to count sessions, measure conversions, and performance, as well as how to run different types of experiments. We made some trade-offs as part of this, but we'll keep working on improvements. And for now, we have solutions for everything to keep iterating on AMP experience. Let's close with talking about results of this effort and our future plan for AMP. As I mentioned earlier, we focus on 3 page types being AMPed at first. 95% of pin pages are AMPed, and we're keeping the 5% holdout, or non-AMP group, to measure the effect of a change. Overall, this amounts for more than 1 billion pages which are available for Google to be indexed. From the conversion standpoint, we've reached parity on this page type, and AMP made pages twice as fast as before. We believe that these numbers could improve after we figure out how to make pagination or infinite scrolling work for AMP. All collection pages are still being evaluated. We have an initial AMP implementation, but it doesn't convert as well as our regular mobile pages. We will need another couple of iterations to fully ship them. In the near future, we're planning to ship AMP to 3 page types mentioned in this presentation. That's fully pin page and all collection pages. We'll work to implement pagination and add more interactive elements on Pinterest's AMP pages. Longer term, we're planning to ship AMP to more page types and start experimenting with progressive web apps. Since having AMP pages often replace deep links in Google search results, we will need to have an unauthenticated experience for users coming to Pinterest via our AMP pages. Progressive web apps are a good way to do that. That's it.